In this session, I will be talking about creating the large smoke plume element for this shot in Houdini and how I approached it, what were the challenges with it. There are additional effects elements in this shot as well. For example, the foreground kind of sand dust, or you can see a bit of fire glowing through the wreckages. I will be not talking about those as they are added by comp magic. So we will only concentrate on the large CG smoke plume. So jumping right into the shot, I can show you what I received with it. So I have the astronaut walking here, walking into the camera. Then when it gets close, the camera pans around, reveals the smoke, and then reveals the wreckage and the ship, and just pans out. So one of the challenges is the size of the scene. It's massive. If I just display Tommy here, you can see Tommy highlighted in yellow, that single pixel right there on the screen. This was a challenge because that also meant that if I dive in here and I show you the separate elements, environment, the wreckage geometry, this is what emits the smoke. This is not the original size. The original size is, if you would see it from the camera, it would be just as 1 or 2 pixels large as Tommy. So and this is not good because this is our smoke reference geometry. So a couple of pixel size wreckage from this camera would never, emit this large amount and long lasting smoke. So we kind of had to balance it and scale up the wreckage, and what you see here is the upscaled size. So we had to upscale it where it is a good balance of, still looks, small in the environment, still doesn't look weird in the environment, still shows the whole scale of the environment, but also that the smoke it will emit still gonna look believable, that this size of the wreckage would be able to create, a large lasting smoke like this. Then the other challenge is the length of the shot. It's 1200 frames long. It's massive. It's way too massive for simulation. It's way too massive for rendering. So if you kind of analyze the shot, then you can kind of realize that the smoke is only visible from 570 roughly, and then from that on it's constantly visible. But the first 570 frames, you don't really have to worry about the smoke. Sort of. Well, the thing is that that's already, anyway, even if it's from 570 to 1200, it's still a massive range. But you do have to simulate kind of pre-roll to make sure that the smoke, by the time you reach 570, the smoke has to arrive to this point here. So this is really challenging because that could add a couple of 100 more frames to the simulation time, and simulating something for this long, which is super high resolution, is really difficult. So you have to balance out resolution and how long do you gonna simulate it. And then the other challenge is that what we wanted is to show the smoke in the helmet. So then you could think that, oh yeah, well then the smoke has to be, ready at its full extent, even on frame 1, which would mean that you would have to have, I don't know how many 100 frames of pre-roll plus the entire, shot range. So that's kind of not possible really. Or like it's really difficult. So what I actually ended up doing, and I can show you now the smoke, is that I ended up basically simulating 700 frames, regardless, where is it, regardless the camera or the animation. 700 frames, I time shifted it, and I just placed it in so that it matches, you know, from 570. Want to make sure that you know, I see the smoke there. And when it comes to the helmet, what trick we could do is that simply instance the smoke once again, and the second smoke would be only visible in the helmet, but I can just time shift it and adjust it, you know, exactly the extent I want it to. Nobody will realize that the smoke on the helmet is actually at a different, you know, timestamp than the one you actually seeing. The other challenge is, which you can already, you know, see if I enable the smoke here. So how do we make the smoke take up the shape of this proxy geometry? And my approach is generally to not to do anything fancy at the beginning. Just try to do the most simple thing possible, see if it works, see if it's acceptable. If it is great, you never had to waste your time doing anything fancy. If it doesn't work, then you can, you know, spend more time on refining it and make sure it's, you know, it matches. And in this case, you know, I could have thought the first instinct, oh, okay, so I can create, you know, some sort of a curve and then use it as a curve force, and then the smoke can swirl around it. Or I could create any kind of velocity field to kind of make the smoke move, you know, push this way, maybe with some sort of a ramp so that it's stronger in the direction of minus X. But I just did not bother really. I did not have to. I simulated this. Nobody, you know, complained, so I leave it like this. So pretty much this was the most easiest problem to solve really. So then jumping into the simulation and sourcing. So it's a basic idea, very basic idea. I just take the geometry, scatter some points on it, and apply some attributes on it that will be, you know, have values based on noise, and then rasterize the points into volumes. So what's happening in a bit more detail. So with an attribute noise node, I create 3 attribute: density, p-scale, and temperature. So p-scale is responsible for volume rasterization. So if you see here volume rasterized attribute, there is a p-scale which will make each point size act larger, therefore you get a bigger blob of volumes. And there is this parameter here, but if you have on the points an attribute, p-scale attribute, this value will be multiplied per point value. So you can control the p-scale per point. Attribute noise allows to declare a list of attributes, in which case each attribute will get the same value. And generally it's a good way with Pyro, because density and temperature are separate fields in Pyro, and to make the source for them a tiny bit different, it's always a very good thing, because it will create more interesting simulation. But this shot is from very far, the smoke is from very far. It's rather simple, and in this case I just did not want to bother to create a second attribute noise and for temperature separately and separately for density. So I just ended up simplifying it, and this will do just fine. But in any other cases, you know, feel free to, you know, do, you know, specify separate density and temperature values. As you can see here are the values. As I said, these are all the same. And let me show you the attribute noise node here. So this is an update in 18.5, what you see here, and this is now version 2.0. If you don't have this bar here, that's because on default we hide this. So if you go to the asset manager and on configuration tab asset bar, display on default is set hide asset bar, but if you click display menu of all definition, then it will always show up. And I think this is very, very handy to see it, because the thing with assets is that they have an asset type, and this is mostly most of the time the name of the asset, so attribute noise. And all of these assets can be namespaced or can be versioned up. And in this case, it's 2.0. And this menu bar shows all the available namespaces, versions, etc. for the same, node type. And this will, allow you to, choose between these. So if I just want to, I can return to the old version and switch between them. So what has changed and why we changed it? So with 2.0, we kind of wanted to speed up the noise generation, and as well we wanted to make the UI a bit more sort of organized into sections, and also make it a bit user friendly and make it quicker to use. So if I just connect it up and I just say I want an attribute float, the first thing usually I do is toggle visualization, and this will create a visualizer here with the same name, and I can further edit it if I want to, but it's okay now, and I can just click it again to disable it, hide that, or show it again. And usually what usually I know always is that what kind of noise I want, and right now positive values mean that my noise is going to be between the positive range 0 till the amplitude. And I can we have a menu here now to quickly change to another range, set 0 center values. So now the values will be between -1 and 1. Or I can specify a min and max values, right away. This is just a simple menu to choose between the most common possibilities you would want. What we also tried to do is simplify the vector parameters. So on default, for example, for element size, you only see one slider which affects all XYZ components the same time. And this is generally most of the time what you want. That's why we do not want to show the per component control on default. But if you click this button, it will show it up, and then of course you can start to scale it up per component based on top of the element scale. And really basically this node is really it really allows you to fine-tune your noises very quickly. So, and generally for this shot, I really like, or generally creating sources, I do not spend much time on it. I don't spend 10 minutes to fiddle around with what noise I want. I really just go like, okay, I know that I want positive values here. I might want to enable the ramp here so that I'm getting values, more like getting actually empty values. I changed a bit of the size of it. Oh, I want animation. Okay, this is kind of okay. This is still too much or too slow. So okay, 15. Okay, this seems right. Fractal wrapping something. Oh, this looks nice. Break it up. Bit too much. Okay, yeah, looks interesting. Done. Like literally this is it, and my aim is to just get right away into rasterizing and just get into the solving stage. And if I really want to you know, later change it, then of course I can, but generally, unless if you don't do anything, you know, crazy noises and so on, then you know, whatever you set, it will not affect your overall simulation as much in this example. So it's totally fine. I am not even bothered to change it to the other type of noises. Simple noises is more than enough, so that I can just quickly go on to and do the next task. And the next node is the velocity, then setting of velocity. So here, again, what I'm doing here is just adding some noise on it, and again, just element size, so that I get this initial kind of, like, you know, more like kind of brushed kind of velocity field here. And then I just add another attribute vector noise to just kind of post-process it to add a constant value of -3 to it, so they point more in the direction of the wind. And then I just have another node actually here to multiply up the density to 1.25. And the reason is because this is the first setup when I first set up this shot, and later I actually had to realize that if I look at the wreckage, it's a bit scattered. So there is a small piece here, a small piece there, and at the moment, after running initially, this small piece was emitting so much density that it was just not looking right. So what I had to do is I split it up the geometry into different parts, like parts A, B, and C. And then all I actually did was to actually not to plug the scatter node here, but actually do it for only this part, and then just copy, paste this node, connecting it here, and then just use this density scale to multiply it. Done, job done. Copy it over, connecting it here. You know, this could emit a bit more, maybe not as much as the main. Merge it back together, job done. Like literally that's it. Right now, for just to simplifying it, I will not do this, and I will just connect it back here to the original one. But this is how I did the final one. Then collision setup. So I do have the ground, so I can create a collision out of it, and I can, because I kind of do not want that the smoke like kind of just presses, like just kind of goes through the ground. So I just created a box, positioned it in the place. I group every point of the ground which is inside the box. I convert the selected group into a primitive group. Just keep only this one. I poly extrude it. Well, because of the minus extrusion value here, the normals will be reversed. So there is this node to, let me show you this guy here. So if you can actually see them, these tiny pink arrows, they're pointing inside. If I reverse them, they point outside. But to be honest, this does not matter for the VDB from polygon node when you convert it to SDF. So just bypass it. I have a velocity node, adjust velocity vector node, so I just declare a velocity 25 pointing upward, so that this is so that the volume kind of rises up from the ground when they're close to it or when they're hitting it, instead of like just sticking there. This is kind of a nice thing to add some sort of a collision velocity to your collisions. And then VDB from polygon will, you know, I convert these into two volumes, collision and V. Collision is an as distance VDB, and V is a vector volume with 3 XYZ components. And the question is why I call them like this. And the reason is, so in the setup tab, collision source on the default, then you can just plug in, I think, the geometry as it is, like this, and then it will do the job for you. But I generally like to VDB convert them before manually, because there could be something wrong with the geometry, etc. I just want to make sure that the VDB looks just right, and I just do it manually. So that's why I change it to SDF plus volume velocity. But here there is nothing to tell you how to do this, unfortunately. So the reason why I know that I have to call them such, it's because I am brave enough to dive inside here, and if I manage to, yeah, collision source volume source here. So this node sources volumes into the Pyro solver, and this is actually set up or initialized to handle collisions. So this is my go-to node, and you can see here that the source volume is set as collision on default, and the other one is set as V, which will end up in collision well. So this is how I can know that these are the two names I have to create. So as you see, I call them such. Then let's approach, well, let's not try to simulate it now here. So what I did in the simulation, and as I said, I only cached out the first 700 frames, and then the rest of it were you know, just time blended. So I simulated 700 frames, but actually out of the 700 frames I'm only using the last 300 frames, because this is when the smoke already kind of got into the right place, or got into the right spatial extension I need. So that's why 400 to 700, and I just scale it up to 1/2200. It's something, these values are just experiments. I just experienced it with it, and I just found that these values kind of sort of give me the right range. So that's pretty much it to it. And when it was coming to the setting up the simulation, so this is the sourcing tab. So this will allow you to set your, you know, sourcing values in a similar fashion as I was just showing you inside here with the collision sources, except this is handled by the source burn here, and these parameters are promoted up here, and these volumes are all related to whatever comes in from the left side of the Pyro solver here. So as I said, I have density, temperature, and V. So these names are all correspond to these names. So if you would call density something like, I don't know, apples, then here you would have to also say apples. It doesn't matter how you call them, but of course, because we want to be, you know, more clear on what we sourcing where, it's nice to kind of give the same sort of names to it. Except V, where the velocity attribute is always referred to V, and this will just convert it to a V. So here you actually I type in V here because it's V, and the target field is always val for velocity in Pyro. And this is a very simple setup. I just use a density scale of 5. The reason why I scaled it is because it's a long simulation. The smoke has to travel a lot, and generally the smoke, even if you do not have dissipation on, it kind of does dissipate over time, just because how, you know, it just kind of gets, you know, moved from voxel to voxel, and over time you will just see some, you know, some degrading of the density, and this is just simply just making sure I have a lot of it. Then temperature, I'm just adding the value up here into it. V and val, I'm just scaling it down a bit. When do I choose operations? Usually I either choose between add and max in varying degree. Really, it depends how I feel like. There is no, like, there are some certain, guidelines how you should do it, but I just do it kind of whatever way kind of comes into my mind, and I don't really have a real science about it, how you can source best. But then going on to the simulation, and I can show you here now. This is kind of the simulation that I made. And here going on to just walk you through the setups. Initially I was using a much higher voxel size, like 0.5 or 6, to kind of just quickly iterate over and get it to the right speed. I think one of the first thing I added was the gas wind sub here inside. So this is so that introduce kind of wind scale. And usually it's a good practice if and I just display the Pyro solver here and then I lock it here. It's kind of good practice to connect up the time scale up to whatever node you do inside, and then you change the parameters according to that. Even though I haven't done this for the other parameters just because I simply forgot them, but generally it's a good practice. But anyway, I set it up the wind direction, and I kind of, wind scale, and I kind of play around with the values a bit, and then, I got it into the, right speed, right direction. I made the time scale to twice as fast, so the volume will move faster. And I just disable temperature cooling. This is exactly because I know that the simulation has to be on a long time. I do not want my temperature to get killed very quickly. A couple of the shape parameters, I just I use only a really small dissipation, exactly because I know that I have to make sure that the smoke lives very long. I created a smaller size scale disturbance. I have a shredding also, not as big block size, and the turbulence is the source size. It's a good mid size here. But what I added here is another gas turbulence node, which is again pretty strong, but the source size is massive here. So this is to kind of get the more interesting kind of breakups here into the shape. And probably I could have pushed it a bit more even. And then here again, just applying another turbulence noise here, and based on density, the density settings here. And when I run this, I actually getting something like this, which is very fast, and actually this does not look the way I want it to. So I could still play around a lot with kind of adjusting them, but at the end what I ended up doing is I have these kind of wrangles, like these dampen nodes, where I can just kind of scale down the velocity really of the volume. And what I'm doing here is actually on the simulation tab here, we have a calculate speed. So this will create a field which will store the speed of the velocity field. So it tells you how fast the volume is moving in a certain voxel, and and therefore, which you can use it in the shape tab. I actually disturbance, shredding, I'm actually not using it on any of these, but when you enable that, you can actually say speed, and then this will use the speed field to control your disturbance. But I did not ended up using that here. But I do use it here because here I can also refer to it as at speed in the wrangle. So what I'm doing here is just a tiny simple bit of code which might look complicated, but it's actually not. And I broke it up into separate sections here. So the normalized speed here is, it means that I'm taking the speed and then I'm just fitting it between the minimum and the maximum value. So whenever my speed is 3, it's gonna give me a value of 0. Wherever the speed max or my speed is higher than 14, it will give me 1, and anything in between. And then I use this normalized speed to look into this ramp and get the values or remap that 0 to 1 range based on this ramp. And then I can use this, kind of remapped values to remap it to my damping. So to between 0 and 0.04. So that will mean where my speed is 3 only or less, the damping will be 0. And where my speed is higher than 14, the dampening is gonna be, rather strong, 0.04. And anything in between again. And what I'm doing here is I'm just complementing the damping. That will give me, so again, if my speed is 3, the damping where it's 0, it will be actually 1. And this is needed because I'm multiplying velocity by the damping. And I actually want that where dampening 0, I want the velocity field to have no effect. And that will only happen if I multiply the velocity by 1, which means I leave it exactly as it is. I cannot multiply it 0 because that will completely stop the velocity there or give completely a zero value. But as a parameter, I kind of want to have it as a dampening of 0, which means, leave it as unchanged. So that's why this kind of complement here. And, that means that wherever the dampening is 0.04, the complement is going to be 0.96. So then the velocity is going to be multiplied by 0.96. That means it will be slowed down. And yeah, basically that's it. I'm applying just another clamp here so that make sure that my damping is always end up between 0 and 1. I do not accidentally want the values turned into minus or larger than 1, which would cause unexpected results. And I pretty much just nudge these values in. You don't want really huge number here because this happens over every iteration, and you do not want that from one frame to another the smoke just completely stops, but you just kind of want to slow it down a bit. And really I just played around with it just a tiny bit, and I was immediately then getting the kind of result like this. One important thing to mention before rendering is exporting the volumes. And by enabling convert to VDB, you can save lots of disk space, and also with resampling the velocity volume. So the velocity volume does not need to be the same resolution as your density. So if you make it twice or even 4 times lower resolution than the density, it will still look okay or barely noticeable, and you will see tons of disk space. And also use 16-bit float will help you a lot. And I only save out density and velocity because I know that it's a smoke, there is no fire, I don't need temperature to create the emission. Then to start the shading, you have two options. There is a Pyro Bake Volume and a Pyro Post-Process node. And these two nodes both responsible for shading the volume in the viewport while also creating a matching shader for mantra renders. And this could be actually rather, I understand it could be rather confusing why we have two nodes for the same purpose, and the reason because in 18.5 we tried to introduce a new way of kind of shading, and we introduced a new Pyro shader. And while we did that, we wanted to make sure that people used to the 18.5 process are still have that option. What I'm gonna show you is basically the new Pyro Bake Volume in this case. So if you put this down, just connect it, and you see that you got the smoke already colored gray because that's kind of the default here. And the next step you can do is, well, actually you can really quickly set up your renders from here. So if you go to the quick setup menu and create lights and cameras, this will create, as it says, lights and cameras, and on top of that a mantra node, so that you are able to render right away. It will ask for where do you want to create it, and I will just choose a new geometry. And you will see that a new camera is created, and it just dropped down, a couple of nodes for me. So what's happening is, if I just organize my nodes here, it created a null node, render Pyro after the Pyro Bake Volume node, and then this null node is object merged into this new geometry because I choose the option to render it as a new geometry, and then it places down a volume light for me, which I do not need because it's not, I don't use emission, it's not an explosion or fire. And I just want to keep the environment light. I have the camera, this is my test camera, this is perfect. And then in the top net, I have a rope mantra node created for me. And this is set it up the way you would want to start your loop depth for smoke. The X-ray image planes has already some image plane set up for you, but they are disabled on default. On the object, you see that the environment light and the Pyro object is set to render. And the engine is set it up for you. The motion blur is enabled, which is important because in this geometry you have to make sure that the velocity blur is on, which is it's on default if you use this quick setup. And I disable ray variance anti-aliasing on default because having it off will make the render just that much faster, and with stochastic samples you can make you don't have to increase the pixel sample as much, but this will work against it, so it will make a bit nicer looking render. And if I just click on now, select this, I just click on it, you see right away I will have a render going here in a moment. There we go. Okay, so this is rather gray now. We don't have anything on it. As I said, we do not need to enable any of these parameters because it's just smoke. And the shader is you actually have a parameter to define which shader you want to use, and the shader on default it's inside this node, and you can see that all of the tabs are kind of synchronized with the Pyro Bake Volume node. And they are connected actually, so these parameters are referencing the Pyro Bake Volume node. So if you change something here, let's say I change the density up to 5, it will not take a bit of time, and then but it will update also the shader. And the reason why it takes time, because it will actually change the properties on the volume, and then the mantra needs to actually reinitialize all the volume as it changed. And this is a bit kind of unfortunate that you have to wait so long for a change, and in that case you have to actually break the material references. So if I just do this now, you will see that the parameters do not reference anymore the interface of the Pyro Bake Volume node, but what this allows me, that now I can really quickly iterate with my mantra render. So it's really up to you how you want to use it. Now the drawback of this, of course, is that the two nodes, you will not have it synchronized. Let's just set it to something like 15 to demonstrate it. To get a good looking smoke, basically the first thing is that if I just drop in some environment map. So if I just go and pick one from my library, just a second here. I can drop on, I think this one will be fine. You will see immediately I get a bit different look, and then I can also just pick something else, and you can see how much an environment light or map actually can influence the shading. So it's also very important that you get a good looking environment map that actually, you know, gives you nice results. And then going back to the shader, one of the things which you can use to make it nice is change the color of the density based on let's say the density. So where your smoke is very dense, and right now it seems like I don't have very dense volume values, I can make it something, you know, very strong, and where it's, you know, already fading off, I can make it, you know, very much, you know, greenish. But to set maybe some normal colors, I can make it, you know, a bit more brownish here, and then much more grayish, and then I just set it back here. So maybe that looks a bit more interesting, maybe not this much brown. But what's really nice in 18.5 and in this new Pyro shader is the absorption color. So with the absorption color, you can actually tell which ray is gonna be absorbed by the smoke as light bounces through. And if I just not pick any color, you see how radical changes I get. But this is actually really nice because you can see that I can create all of this nice looking color variation in the smoke just by changing one color parameter. Though again, you would have to know which colors to choose, of course. And usually a good thing is when I would wanna, you know, like if I don't wanna do anything realistic, I can just go in and I can just, you know, create something really nice looking here. But if I want to be, you know, wanna do something more realistic, I would just go on to this this brown one, and then I would start to play with the saturation and the hue values to kind of get that working. And then you can see that I immediately getting this again more of this brownish fall off, and and I can just play with it now. I can make it even, you know. So it gives you a loads of control over the look. Let me just trying to change it back. No, this is a bit too much. Yeah, that looks something like interesting. And then of course scattering phase, it's important to set up so now I can get a lot even more interesting colors into my smoke. Also shadow color, you can also kind of ramp the shadow colors. So right now, you know, I can even play on a bit more, so create even more, even abstract looking, you know, kind of smoke. So, and I think I leave it like that because I kind of like the smoke. Of course, for the shot, this is not how I set it up, but I just kind of wanted to show you the kind of parameters you can play with. Also, if you would have temperature, it's really nice to enable the use control volume, and you could scale the density based on another volume, and on default, the control volume would be the temperature, and some of the explosion, actually maybe almost, I think most of the content library explosion use this method to create some more interesting looking detail into the explosion. And pretty much I think that covers everything you need to know about it. Of course, I rendered this with a different environment map I got, and basically I just passed on the cache to render it for the final shot, and that was it really.